All right, well, we're going to keep on moving forward with quadratics, and we're going to be solving them. And first off, we're going to solve the quadratic equations that only have our a and c, okay? And so that will be using just square roots because we will not have a middle term. So first thing we need to do is we need to make sure we isolate the x squared. And so for number 1, we're just going to divide both sides by 5. And we get x squared equals 16. Okay, and we need to square root that. Now, the square root of x squared is x. And square root of 16 could be a positive 4, but it could also be a negative 4. I'm not sure which one, so I'm going to have a positive or a negative 4. Okay, so basically what that's telling you is your x-intercepts, it's your roots, it's your solutions, okay, it's your zeros, that at positive 4 and at negative 4 we have roots, we have x-intercepts. So you're going to have a parabola that looks similar to that, okay? Obviously, this would go through the root, okay? Moving on, looking at number 2, looking at this, it looks like we have a different form, but we're going to still try to isolate the squared piece, okay? And when you're solving, you want to make sure you add or subtract before you multiply or divide, okay? It's not PEMDAS. We're not evaluating something. We're not trying to find the answer to a math problem. We're trying to find a missing number, okay? So first thing we're going to do is go ahead and add 3 to both sides. And I'm left with 3x plus 1 squared equals 12. Again, we're trying to isolate the squared piece. I'm going to divide by 3 next. And I get x plus 1 squared equals 4. Well, conveniently, we have isolated the squared. And the reason we want to do that is so we can use the square root method. So I can square root both of these, okay? And I'm left with x plus 1 here. But on this side, I'm not sure if it's a positive or a negative 2. So I have to make sure I put both of the answers there. So that means I'm going to have to solve twice with both positive and negative 2. And what I mean by that is I'm going to have x plus 1 equals positive 2. And I'm going to have x plus 1 equals negative 2. Because I don't know which one it is. Just like when we were solving absolute value, we weren't sure if what was inside was positive or negative. I'm not sure if the square root should be positive or negative, okay? So I have to solve for both. So when I subtract 1, I get x equals 1. And here when I subtract 1, I get x equals negative 3. And again, those would be my 2 roots, my x-intercepts, my zeros, my solutions, okay? All right, so moving on to number 3. We have 3, which is 7. X plus 2 squared equals 336. We're going to isolate the squared piece. So by dividing by 7, I can do that. And I get x plus 2 squared left over here. And on the right side, I get 48. Okay? So I am going to take the square root of both sides, and I'll have x plus 2 left over here, and on this side I have the square root of 48 is not a perfect square. Okay, I know it's 6 point something, it's very close to 7, but we are not going to try and round this because we're going to be inaccurate if we do that. So what we're going to do is we are going to simplify our square root. Okay, so if you recall in Algebra 1, we can find all the factors of 48 and determine what the simplified root would be. Okay, so I can start by saying, okay, this can be 8 times 6. All right, but I can simplify that even more until I get only prime numbers. So 2 and 4, 2 I need to stop, 4 I can keep going, 2 times 2. 6. I can get 2 times 3. All right, I've gotten only prime numbers left over. Okay, so what I'm going to do is I'm going to look at any pairs because a pair will bring out a root. Now, again, I don't know if it's going to be positive or negative, so I'm going to have to put both of those options in the front there and find the pairs. So, a pair of 2's. Well, the square root of a pair of 2's is just 1 2. The square root of a pair of 2's is just 1 2. So I have 2 2's on the outside, and so they're going to multiply by each other. But I have a 3 that doesn't have a friend, so that 3 is going to stay in the radical. Okay? So, right now I have x plus 2 is equal to plus or minus 4 square root of 3. I still haven't solved x though, because I still have that x plus 2. So I need to subtract 2 on both sides. And so what I'll have then is x equals negative 2 plus or minus 4 square root of 3. And the way we need to the reason we need to set it up like this and keep that negative 2 in the front is because of this plus or minus. Okay, that way it doesn't look so funny just sitting out in the front by itself. We can have the negative 2 plus 4 square root of 3 and negative 2 minus 4 square root of 3. All right, so notice these next equations have a b term, okay? Remember, we're dealing with standard form right now, which is ax squared plus bx plus c, okay? And so what we're going to try and do on these is use a set of steps that would be different from the ones we used earlier. So I'm going to start by multiplying my a times c. So a times c, which is 1 for a, times c, which is negative 28. Okay, so that's going to give me negative 28. Well, I need to know, okay, which factors are going to give me negative 28? What can I multiply together to get that value? Okay, so what I have is negative 1 times positive 28, negative 2 times 14, negative 4 times 7, and then the reverse. Positive 1 times negative 28, 2 times negative 14, and 4 times negative 7. Which of these would give me 3? Okay, and that would be negative 4 and positive 7. So we're going to rewrite this equation as x squared minus 4x plus 7x minus 28. Okay, so that negative 4x and the positive 7x, okay, really just still make 3. But the reason we're going to separate it out is it's going to make it easier for us to factor, okay? And so what we're going to do now is kind of group this and be like, okay, these two can go together and these could. Okay? Well, we need to factor out a factor out of each of those. So for the first one, they both have an x. So I'm going to take out an x. And x times what makes x squared? Well, x times x makes x squared. Okay? And we want to know, okay, what times x makes negative 4x? Well, x times negative 4 makes negative 4x. Okay? So we factored out that one. Now we have the second one. And we have 7x minus 28. We need to take out a common factor from that section. So 7 would be a good factor to take out. So I need to take out a 7 out of both of those. So here we took out x. This one we're taking out 7. So I have an x left and negative 4. Notice how both of these parentheses are x minus 4. So they're basically a common factor of both of these sections. So x minus 4 is going to have a parentheses by itself, and then whatever's left, which is x plus 7, is going to be the second piece. We have factored that equation, okay? Now we have both of the intercepts. We could find the solutions very easily, okay? Because I'm going to have x minus 4 equals 0, and x plus 7 equals 0, which again, remember it told us our x-intercepts last time when we were dealing with the equations. Now it's going to tell us our x-intercepts again. Which are the solutions? Which are the zeros? Okay, so we're going to have x equals 4 and x equals -7. So all we're doing on all of these solving problems are finding the solutions, which are really just the zeros or the x-intercepts. All right, moving on to number 5. Remember, we're going to divide out any common factors. So I have a 3, a 10, and an 8. We're not going to have anything in common to factor out. So we're going to go straight to multiplying A times C. Okay, so 3 is our A, our C is -8, and we get -24. So we need to think about, okay, what's going to make -24? Well, we have, all right, so we have 1 times -24, we have -1 times +24, we have -2 times 12, we have +2 times -12. We have a whole bunch of different ones if we keep going, but I see that this one is going to give me 10 when I add it, which is what I need for my B. So that would be a good one to use. And we're going to rewrite the equation, remember? Okay, we're going to recreate that equation with the new numbers that we just found that would equal 10. So we're going to have 3x squared minus 2x plus 12x minus 8. Because remember, this -2 and +12 still make that 10 up there. Okay, equals 0. All right, so when I do that, my next step is to take out any common factors of each piece of my equation. Okay, because I'm going to group these two and these two. They're going to be friends. They're going to be grouped together. And we're going to pull out any common factors. Okay, so for this first one, I can take out an x. So x is going to go on the outside because I'm dividing it out. And inside, I'm going to have 3x because x times 3x makes this 3x squared. Minus 2x divided by x is going to give me just 2 here. All right. Now for the second piece, I have a 12 and an 8. Common factor would be 4. So I'm going to take out a 4 out of both of those and put it on the outside. I'll be left with 3x minus 2 equals 0. All right. Notice how we have 3x minus 2 for both of our parentheses. So that is going to be its own factor, 3x minus 2. And I have x plus 4 left. X plus 4 equals 0. And the way you're going to solve is set each piece equal to 0 to find x. So 3x minus 2 equals 0. X plus 4 equals 0. Add the 2 over, I get 3x equals 2. Divide by 3, x is 2/3. X plus 4 equals 0. Solve for x, we get x equals -4. So these are my two solutions, roots, zeros, x-intercepts. Okay, then we have number 6. Remember, first, take out any common factors if you can to start with. So I'm going to take out a 5, and this is not going to change my answer. If you wanted to deal with these larger numbers, it will not change your answer. But you might as well work smarter, not harder. Okay, so I have 2x squared minus 11x equals -12. Well, I don't have a c, and the reason for that is because my c has come over here. We need to move it with a and b, okay? So I'm going to add the 12 over here, and I'll have 2x squared minus 11x plus 12 equals 0, okay? So, step 2, we need to make sure that we multiply a times c and get a table of values. So 2 times 12, which is 24. Okay. All right. But I'm noticing that I'm trying to get a negative. Okay. My a times c is positive, but I'm trying to get a negative. Well, the only reason I'm going to be able to get a negative 11 for my b is if I have two negatives to make a positive 24. So I have negative 1 and negative 24. That won't make negative 11. Negative 2 times negative 12. That won't make negative 11. Negative 3 times negative 8. That looks like a winner. So remember, I'm going to rearrange this negative 11. I'm going to use negative 3 and negative 8 in its place. So I have 2x squared minus 3x minus 8x plus 12 equals 0. All right, so next step, we're going to take out common factors from each group. And we're going to group them with the first two terms, okay, and the second two terms. All right, so the first one is usually your x. So if I divide x out of both of those, I get 2x, because x times 2x is 2x squared, minus 3x divided by x is just 3. Now these next two terms, looks like I can pull out a 4 or a negative 4, whatever you prefer. I'm just going to go ahead and take out a negative 4. So that's going to give me 2x, because negative 4 times 2x is negative 8x. And this is going to give me a negative 3 equals 0. And that was the best way to go, because then we had the same, because we had a positive 2 here, we wanted this to be positive. Because remember, we want them to match. So it was best to take out that negative 4. All right, now we have 2x minus 3, which is in both of them. That's going to be our common factor for our final equation. And then what's left after I take out 2x minus 3 is just x minus 4 equals 0. Well, your final solutions are not until you set each piece equal to 0. So 2x minus 3 equals 0. I get 2x equals 3, which x will be 3/2. Okay, and the second one I have x minus 4 equals 0, which x equals 4. So these will be my two solutions, my two roots, my two zeros, my two x-intercepts, which is what I'm looking for. Okay, another option that could happen is when your c is 0. You don't have a c, okay? So we're trying to figure out what our n would be so that we could find a solution. Well, remember, first step, take out any common factors. So I can take out a 5 out of both of these, and also an n. So if I take out a 5n, then on the first term, I'm going to have 9n left, because 5n times 9n is 45n squared. And on the second part, 10 divided by 5 is 2, but the n's are going to cancel out, equals 0. Well, that ended up nice. So basically all I have to do now is set each piece equal to 0. 5n equals 0, 9n plus 2 equals 0, and find my two solutions. That's always why it's always nice to take out a common factor at the beginning. Okay, just double check that if you have any. So in here will be 0 when I divide by 5. Here I have 9n equals negative 2. But when I divide by 9, I get negative 2/9. Okay, so there's my two roots, my zeros, my x-intercepts, my solutions, those two right there. Okay, so make sure if you're doing this on your own paper that you do at least summarize part of this so you know what's going on. I don't want to just see the answer. Okay, in case you hadn't heard, there is something called velocity, and it's basically denoted by this equation right here. And so they give you an example for this graph. If the initial height is 200, then that's going to be your C. So there's basically no B term. Okay, so for a science project, we have a container that allows an egg to fall safely, but it drops at a height of 50. Okay, remember this right here is your initial height, your height at time 0. Okay, so it says write a function. Well, the only thing we are going to change is the initial height, which is 50. So that's all we had to do for that little piece. Okay, it's still going to be negative 16t squared, but it's starting at the height of 50. But what we need to do is interpret h of 0 and h of 1 and subtract those two, okay? And basically what that's going to do is tell us how much it dropped between 0 and 1 second, okay? So h of 0 means t is 0, and h of 1 means t is 1. So we need to find each piece and subtract. So what I'm going to do, just to make it simpler on you and myself, is I'm going to say, okay, negative 16, 0 squared plus 50, that's going to be for this first piece, minus all of that together, 16 times 1 squared plus 50. I want to subtract that whole piece. I don't want it to just subtract 16, so that's why I have to have all that in parentheses so it'll stay together. I want to subtract everything from that second equation. Okay, so basically this first piece is all going to be 0, so I have 50 minus, in here, remember I'm just evaluating, I'm not trying to solve for an x that I have in there, I'm just trying to find a final number, not that represents a variable, just the final height. So 16 plus 50 is your 66, all right? So your final answer would be negative 16, which means that's how much it fell, 16 feet, okay? From the original height at time 0 to the height at time after 1 second, it has fallen 16 feet, okay? Okay, well, I didn't realize that we were solving on part A. We need to go back up there and solve. Look at me. How long does the container take to hit the ground? Well, it tells you 3.54 comma 0 on the graph of 200, but that's not for the graph when it started at 50. Okay, so what you're going to need to do is solve for your zeros, solve for your x-intercepts, all that good stuff for this equation. So I want my y to be 0 because that's where my x-intercept is. Okay, so I'm going to get rid of all this to kind of get things out of the way. And that way we have room to solve part A. I apologize. So we want h, which is our height, we want it to be 0. And solve for t. At what time will it be 0? Okay? Well, I'm going to subtract the 50 over, and I get negative 50 equals negative 16t squared. Why did I do that? Because I noticed there was no b. Okay? And since there's no b, then I can just solve by square root. I do not have to factor. Okay? So what I'm going to get for t squared is 50 over 16. Okay? And that's for t squared. I divided both sides by negative 16, and this is where I'm at. So when I square root, my final answer is going to be, now since we want actual seconds and to make it more real world and make more sense to you, I would actually put this in the calculator and round to the thousandths place. Okay, and when you put it in the calculator around the thousandths place, it's going to be 1.768 seconds. That's the time. And notice I did not use any negatives. Why? Because you cannot go back in time. You cannot have negative time. Okay, you can only have positive time, just like you can't have negative distance. Okay, so we don't want, it's not before we started, before we got up to where we were going to drop the egg. Okay, it's after time 0, so 1.768 seconds.